So for my a and b values, I chose 12. The problem says let z equals a minus bi. So in my situation, z would equal 12 minus 12i. And to find the polar form of this equation, we must use the modulus or in the argument. The modulus is the hypotenuse of the right triangle created by point A and B. So the modulus would be 12 radical 2, because 12 and 12 create a 45, 45, 90 triangle, and using special right values, we can figure out this hypotenuse. And for the argument, we have to use the negative 12i. We have to use the inverse tangent to find the argument. So the inverse tangent would be of negative 12 over 12 would be negative 45, which is positive 315 degrees, as you can see right here. And we have to put that into radians to put it in the correct de Morse theorem form, which would be the 315 converted to radians would be 7 pi over 4. So the equation would be 12 radical 2 times CIS, or cosine I sine 7 pi over 4. So the problem's asking us to place, using de Morse theorem, to put this to the 7th power, or raise it to the 7th power. So we place it, to do this, we put the modulus to the 7th power, as you can see right here, but you multiply the argument by 7. So the equation would be 12 radical 2 to the 7th times CIS negative 49 over 4, negative 49 pi over 4. That's raising it to the 7th power. And the next part is asking us to find the 5th root of the equation. So the 5th root, the modulus, you just 5th root it. You would 5th root it. So that'd be 5 root 12 root 2. And then the argument's a little more work. To find the first argument, we must divide the original one by 5, because it's saying 5 roots. And to find the first argument, but now we have to find the 4 other arguments, as you can see right here, because we're creating roots. So each of these are 72 degrees apart, because 360 divided by 5 is 72, because it's a full circle, which is 2 pi over 5 radians. So we take this first one, which we got by dividing the original argument by 5, 7 pi over 20, and add 2 pi over 5. So you keep doing that, add, and you put them with the moduluses, and you get these 5 roots.